In this video, you will learn how to solve for the determinant of a matrix. First, let's define what a determinant is. The determinant is a special number that can be calculated from a matrix. And you take note that the matrix has to be square, which means that it has to have the same number of rows and columns like this one here, this example here. So it could either be a 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, and so on. And the symbol for determinant is two vertical lines either side. Say, for example, we're given matrix B. Let's say B is this one. So the symbol for determinant would be this one. If we need to solve for the determinant for matrix B, it is the same symbol as the absolute value. So it is represented by this notation here, or by writing the abbreviation of determinant, DET, then your matrix. And again, take note that to calculate for the determinant of a matrix, the matrix must be square, which means the matrices have to have the same number of rows as columns. Now, how to solve for the determinant? For 2 by 2 matrix, which has 2 rows and 2 columns, let's say we're given matrix A, which has components A, B, C, D. Then to solve for the determinant would just be we multiply A and D minus B times C. A times D minus B times C. It would be easier to remember when you think of a cross, like you just cross multiply. You multiply A and D, and then minus B times C. All right, let's solve some problems here. What if we're given this matrix C, which has these components? All right. Right, then solve for the determinant of matrix C. So that would just be 11 times 12 minus negative 8 times negative 1. So 11 is our A, negative 8 is our B, negative 1 is our C, and 12 is our D. So this would be 11 times 12 minus negative 8 times negative 1. And 11 times 12 is just equal to 132 minus negative 8 times negative 1. That would be positive 8. Then we have 132 minus 8. This would give us an answer that is 124. Therefore, the determinant for matrix C is equal to 124. All right, let's try another problem for 2 by 2 matrix. Let's say we're given this matrix Y, which has components to negative 3, negative 1, 4. Then we solve for the determinant of matrix Y. So this is just 2 times 4 minus negative 3 times negative 1. And 2 times 4 is just equal to 8. Minus negative 3 times 1 is positive 3. And this would give us an answer of 5. So that is the determinant for matrix Y. Okay, but how about if the given matrices are 3 by 3, 4 by 4, and so on, and higher? So how are we going to solve for the determinant? So we'll see for the 3 by 3 matrix. So when you say 3 by 3 matrix, that means it has 3 rows and 3 columns. Say we're given this determinant here and has the components A, B, C, D, E, F, G, H, I. So to solve for the determinant of matrix B, so this is what we're going to do. So the components in the first row of matrix B, we have A, B, and C. So what we're going to do here is to multiply first A by the determinant A times the determinant of the 2 by 2 matrix that is not in A's row or column. So those components that are not in A's row or column are these ones. So we just get the determinant of that. So that would be A times E times I minus F times H. And then minus, again, the same with B. B times, okay, the components that are not in B's row and column are D, G, and Fi. So that would be D times I minus Fg. Then plus for C, that will be C times, okay, the components that are not in C's or row or column are D, E, G, H. So that would be DH, D times H minus E times G. So it may look complicated here, but it's easier to remember the pattern here. Okay, and then you just have to sum them up, but you have to remember the minus in front of B. Or you can just simply write this as, okay, A times the determinant of E, F, H, I minus B times D, F, G, I plus C times D, E, G, H. Okay, so this is the pattern on how to solve for the determinant for matrices 3 by 3, 4 by 4, and higher. And this method of calculation is called the Laplace expansion. And the pattern here is easy to remember. Now let's try solving some examples for 3 by 3 matrix, 4 by 4, and so on. All right, let's say we're given this matrix A, negative 1, 4, 2, okay, 5, negative 2. Okay, now let's solve for the determinant of matrix A. Okay, using that pattern or method, okay, let me write the method here. E A times EFHI minus B times DF GI plus C times DE GH. All right, so let's apply this method. So that would be -1 times -3602 minus 4 times 5162 plus 2 times 5 -3 1 0. Okay, this would be -1 times, okay, let's solve for the determinant of this one. So this would be -3 times 2 minus 6 times 0. Then -4. All right. -4 times this one. 5 times 2 minus 6 times 1. Then plus 2 times this one. 5 times 0 minus -3 times 1. Let's calculate this one. Right. Okay, then this would become, okay, -1 times -3 times 2 is -6 minus 0. Then -4 times 10 minus 6 plus 2 times 0 minus -3, or 0 plus 3. Then we simplify. This is just -1 times -6. This would give us +6. Okay, +6 minus 4 times 10 minus 6 is 4. 4 times 4 is 16 minus 16. Then 0 plus 3 is 3. 3 times 2 is 6. And this would give us an answer of -4. Therefore, the determinant of matrix A is just equal to -4. Alright, let's try solving another problem for 3 by 3 matrix. Okay, let's say we're given matrix M with these components. Alright, so we solve for the determinant of matrix M. So this is just 8. Okay, 8 times 11 times 6 minus 2 times -9. So 11 times 6 minus 2 times -9. Then minus 5 times this one and this one. 5 times 6 minus 2 times 9. Then plus 4 times this one and this one. 5 times -9 minus 11 times 9. Then we simplify this one. Alright, so we have here, okay, 8 times 11 times 6. 11 times 6 is 66. Minus 2 times -9 is -18. Times negative, that would be +18. And then minus 5 times 6 is 30. Minus 2 times 9 is 18. And then 4 plus 4 times 5 times negative 9 is negative 45, minus 11 times 99, that is negative 99. And then we simplify, it will be 66 plus 18 times 8, that would give us 672. All right, and then negative 5 times 30 minus 18, it would give us negative 60. And then 4 times negative 45 minus 99, that would give us negative 576. So that would be 672 minus 60 minus 576. Okay, and this would give us an answer which is 36. Therefore, the determinant of this 3 by 3 matrix M is equal to 36. And for the other matrices of 4 by 4 and higher, it will be the same pattern. It will just continue. So you just have to take note the plus minus sign pattern. You just have to remember it. So, okay. All right, it will be the same pattern. So this is for the 4 by 4 matrices, and then for higher matrices 5 by 5 and so on. So you just have to remember this pattern. Take note of the signs. So be positive, negative, or plus, minus, and so on. So you start with the first row of the matrices, and then you multiply each of the components there by the determinant of the matrix that is not in that component's row or column, and the pattern just repeats or continues. Right. And actually there are other methods in solving for the determinant of matrices, but this method here that I just shown you, this is the easiest to remember, the Laplace expansion.